All right, let's dive into something we use every single day but probably don't think about much: Earth's address system. We're going to break down latitude and longitude, and stick around because their connection to time is pretty mind-blowing.
Okay, so think about this for a second. How does your phone, the one right in your hand or pocket, know exactly where you are on this giant planet? We're talking a rock that's almost 25,000 miles around. It feels like magic, right? Well, it's not. It's all thanks to a grid.
And this is basically what that grid looks like. It's this huge, invisible web of lines wrapped all the way around the Earth. You can think of it just like a street map. You know, where Main Street and Fifth Avenue cross? That's one specific spot. This grid does the same thing, but for the entire planet, giving every single place its own unique address.
So why go to all this trouble? Why do we even need this system? Well, let's get into why it's so crucial for finding, anything and everything.
The problem is pretty obvious when you think about it. Earth is just massive. Yelling, "I'm somewhere in the Pacific Ocean," isn't going to help anyone find you, right? So, to locate anything with real precision, whether it's a boat, a city, or even your own house, we had to come up with a foolproof mathematical system. And that system is this grid.
Okay, so let's break this address system down into its two parts. First up, we're going to look at the horizontal lines, the ones that go side to side. These are the lines of latitude. Now, the official definition talks about angular distance, which sounds complicated, but it's not. Picture this. You draw a line from the very center of the Earth out to the equator. Then you draw another line from the center out to where you're standing. The angle between those two lines, that's your latitude. It's a super precise way of measuring how far north or south you are from the equator.
And these lines have a nickname: parallels. It's a perfect name, really, because they run perfectly parallel to the equator and to each other. They never, ever cross. The equator is our big starting line, our 0-degree mark.
Now, technically there's a line for every single degree, but there are a few famous ones you've probably heard of. Of course, you've got the equator at 0. Then there are the Tropic of Cancer and the Tropic of Capricorn. They basically fence off the tropics. And way up and way down, you've got the Arctic and Antarctic circles. The whole thing tops out at the North and South poles, which are at a perfect 90 degrees.
All right, so that takes care of our north-south position. But that's only half the address, right? We still need to know our east-west spot. And for that, we need to bring in the other set of lines, the vertical ones. We call these longitude.
And hey, just like latitude, longitude is all about angles. But this time, instead of measuring from the equator, we're measuring how far east or west we are from one very specific, internationally agreed-upon starting line.
So what is this all-important line? It's the prime meridian. And here's a wild piece of trivia for you. Before 1884, there wasn't one. It was kind of a free-for-all. Different countries just picked their own starting points. Can you imagine the chaos? Finally, everyone got together and agreed that the line running through Greenwich in London would be the official 0 degrees starting point for the whole world.
Okay, quick summary. Latitude lines, or parallels, they run east-west, measure how far north or south you are, and they never touch. Longitude lines, or meridians, they run north-south, measure east-west, and they all meet up at the poles. Simple enough. But here's the twist. Longitude is hiding a secret superpower.
And this, folks, is where it gets really, really interesting. Because longitude isn't just about finding your where, it's also the secret ingredient to figuring out your when. It's literally how we tell time across the entire planet.
Yeah, so we've established that latitude is great for figuring out distances. But longitude's secret second job? It's all tied up with the way our planet spins. It is the key that unlocks local time.
And it all comes down to one magic number: 15. Think about it. The Earth spins one full circle, that's 360 degrees, in 24 hours. So if you just do the quick math, 360 divided by 24, you get 15. That means every single hour, the Earth turns 15 degrees of longitude.
And boom, there it is. That's the link. For every 15 degrees of longitude you move across the face of the Earth, the clock changes by exactly 1 hour. Your location and the time on your watch are physically, fundamentally connected. It's incredible.
Okay, but do you add an hour or subtract an hour? It's actually super intuitive. The sun rises in the east, right? So places to the east are always ahead in time. This leads to a really simple little memory trick. East, you gain time, so you add EGA. And the opposite is true for the west. West, you lose time, so you subtract WLS. Easy.
Let's put this to the test. Say it's 12 noon in London, right there at the prime meridian. Now let's hop over to Chennai, India, which is about 80 degrees east. Remember our rule? East, gain, add. So we add about 5.5 hours, and yep, it's 5:20 in the evening there. Now let's go the other way, to New York City, which is 74 degrees west. West, lose, subtract. We take away almost 5 hours, and it's just past 7 in the morning. It works perfectly.
So this system is genius, but it actually creates one last, pretty huge problem. If every single town, down to the minute, set its clock based on its exact longitude, well, things would get really messy really fast. We needed a way to simplify.
Seriously, just imagine it. You drive to the next town over, just a few miles away, and you'd have to reset your watch by like 3 minutes. Trying to schedule a train ride would be an absolute nightmare. The whole world would be a jumble of slightly different times. Total chaos.
And the solution to that potential chaos is the time zone map. Instead of infinite local times, the world was carved up into 24 standard time zones. Each one is roughly 15 degrees of longitude wide. And here's the key. Everyone inside one of those bands just agrees to use the exact same time. It tidies everything up so we can all function.
But of course, this gets tricky for huge countries. I mean, countries that are really, really wide from east to west can't just have one time zone. It wouldn't make sense. That's why you see countries like Russia and the US having 9 different time zones, and Canada having 6. It's just a practical way to deal with their enormous size. So when you boil it all down, this whole grid of latitude and longitude is way, way more than just lines on a map. It's like the invisible operating system for our planet. It runs our navigation, our communication. It syncs up the entire world. It literally puts us all on the same clock.
And that's really the whole story. So I'll leave you with this question. Now that you know how this grid works, where do you see it in your own life? I mean, from your daily schedule to global shipping to just tracking a pizza delivery on your phone. This invisible system is running in the background, shaping just about everything.